purpose of bonding is to create a low impedance path from the equipotential plane to ground. Water lines are generally not considered effective electrical paths to ground. How water is supplied to the house is a crucial factor. If the water source is a well or a spring, the most reliable approach is to establish a connection using a jumper or grounding electrode conductor from the equipotential plane, typically the main service panel, to the well casing. Alternatively, if there is a submersible well, the connection can be made to the pump control enclosure. For properties supplied by city water, it is essential to determine whether the water supply utilizes metallic or plastic pipes. If the water supply is delivered through a metal pipe, it can serve as an effective ground, enabling bonding to it. However, if the water supply is delivered via plastic pipe, it is necessary to contact the water supplier for guidance. They may have a grounding system already established and may have specific requirements for bonding to the system. In cases where non-metallic water lines are used, the metallic components such as faucets and drains may require supplemental bonding to ensure electrical safety and minimize potential differences. This can involve connecting a bonding conductor from the faucet or drain to a nearby grounded metal component or to the grounding electrode system. The specific requirements for bonding metallic components and plumbing systems supplied by non-metallic water lines can vary depending on local electrical codes and regulations. It is important to consult the relevant codes and regulations, such as the National Electrical Code, to determine the appropriate bonding methods and conductor sizes. If the water supply is non-metallic, there is no metallic water piping system to use as a grounding electrode. Other grounding electrodes should be utilized, such as a ground rod, ground ring, or concrete encased electrode. The size of the grounding electrode conductor is determined by NEC Table 250.66. It is generally recommended to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations and to determine the best bonding practices for a specific situation. The goal of bonding is to minimize the risk of electric shock by creating a low impedance path for fault current to flow back to the source, thereby tripping a circuit breaker or ground fault circuit interrupter. In addition to bonding metallic components, it is also important to ensure that all electrical equipment in the vicinity of the plumbing system is properly grounded. This includes items such as water heaters, pumps, and electrical outlets. Proper grounding helps to minimize the risk of electric shock and protect against equipment damage. Regular inspections of the grounding and bonding system are recommended to ensure that all connections are secure and that there are no signs of corrosion or damage. Any issues that are identified should be promptly addressed to maintain the integrity of the system. In some cases, it may be necessary to install a supplemental grounding electrode, such as a ground rod, to improve the overall grounding of the electrical system. The location and installation of supplemental grounding electrodes should be in accordance with the National Electrical Code and local regulations. It is important to use listed or labeled grounding and bonding equipment that is suitable for the intended application. This helps to ensure that the equipment meets industry standards for safety and performance. The use of proper tools and techniques is also essential when installing grounding and bonding conductors. This includes ensuring that connections are tight and that conductors are properly protected from physical damage. When working on electrical systems, it is important to always energize the circuit before making any connections or repairs. This helps to prevent the risk of electric shock. If you are not comfortable working on electrical systems, it is best to consult with a qualified electrician. They have the knowledge and experience to safely and effectively address any electrical issues. Firstly, it is important to understand the basic principles of electrical grounding and bonding. Secondly, familiarize yourself with the relevant electrical codes and regulations, such as the National Electrical Code. Thirdly, consult with a qualified electrician or electrical inspector if you have any questions or concerns. 1. Proper grounding and bonding are essential for electrical safety. 2. They help to minimize the risk of electric shock. 3. They protect against equipment damage. The National Electrical Code, specifically Article 250, provides detailed requirements for grounding and bonding electrical systems. It is important to familiarize yourself with these requirements to ensure compliance. Bonding is the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Grounding is the act of connecting the electrical system to the earth, typically through a grounding electrode system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground rings, or concrete encased electrodes. The grounding electrode conductor connects the grounding electrode system to the electrical system, typically at the main service panel. Equipment grounding conductors are used to connect the non-current carrying metallic parts of electrical equipment to the grounding system. This helps to ensure that any fault current will flow back to the source and trip a circuit breaker or ground fault circuit interrupter. Ground fault circuit interrupters are designed to protect against electric shock by detecting small amounts of current leakage and quickly interrupting the circuit. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults in electrical wiring. Surge protective devices are designed to protect against voltage surges caused by lightning or other events. Regular testing of ground fault circuit interrupters is recommended to ensure that they are functioning properly. This can be done using a test button on the device. When installing electrical wiring, it is important to follow all applicable codes and regulations. This includes using the correct wire size, ensuring that connections are tight, and protecting wires from physical damage. If you are not sure how to properly install electrical wiring, it is best to consult with a qualified electrician. They have the knowledge and experience to safely and effectively install electrical wiring. When working on electrical systems, it is important to always wear appropriate personal protective equipment such as safety glasses and gloves. This helps to protect against electric shock and other hazards. Never work on electrical systems when you are tired or distracted. This can increase the risk of making a mistake. If you are taking any medications that may impair your judgment or coordination, it is best to avoid working on electrical systems. Always be aware of your surroundings when working on electrical systems. Make sure that there are no tripping hazards or other obstacles in your work area. If you are working in a confined space, make sure that there is adequate ventilation. Never work on electrical systems in wet or damp conditions. This can increase the risk of electric shock. If you are working near water, make sure that all electrical equipment is properly grounded and protected by a ground fault circuit interrupter. Be careful when using metal tools near electrical equipment. Metal tools can conduct electricity and increase the risk of electric shock. If you are working on a ladder, make sure that it is stable and that you are not reaching too far. Reaching too far can cause you to lose your balance and fall. Always use caution when working on electrical systems. Electricity can be dangerous if it is not handled properly. If you are not comfortable working on electrical systems, it is best to consult with a qualified electrician. They have the knowledge and experience to safely and effectively address any electrical issues. Remember that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. They can help you determine the best grounding and bonding practices for your specific situation. The effectiveness of a grounding and bonding system depends on several factors, including the quality of the materials used, the workmanship of the installation, and the maintenance of the system over time. Regular inspections and maintenance are essential to ensure that the system continues to function properly. If you notice any signs of corrosion, damage, or loose connections, it is important to address them promptly. Ignoring these issues can compromise the safety and effectiveness of the grounding and bonding system. When making any changes or additions to an electrical system, it is important to ensure that the grounding and bonding system is properly updated to accommodate the new equipment. This may involve adding additional grounding electrodes, bonding conductors, or ground fault circuit interrupters. It is also important to consider the potential impact of any changes or additions on the overall electrical system. If you are not sure how to properly update the grounding and bonding system, it is best to consult with a qualified electrician. They can help you assess the situation and recommend the appropriate course of action. In some cases, it may be necessary to perform a ground impedance test to verify the effectiveness of the grounding and bonding system. This test measures the resistance of the ground path and can help identify any potential problems. The results of the ground impedance test can be used to determine whether any improvements are needed to the grounding and bonding system. Ground impedance testing should be performed by a qualified electrician using specialized equipment. The test results should be documented and kept on file for future reference. The National Electrical Code requires that all electrical equipment be properly grounded and bonded. This is to protect against electric shock and to minimize the risk of fire. The NEC provides detailed requirements for grounding and bonding, including the types of grounding electrodes that are permitted, the size of the grounding electrode conductor, and the methods for bonding metallic parts. The NEC also requires that all ground fault circuit interrupters be tested regularly to ensure that they are functioning properly. Failure to comply with the NEC requirements for grounding and bonding can result in fines, penalties, and even legal action. It is important to be familiar with the NEC requirements and to ensure that all electrical work is performed in accordance with these requirements. If you have any questions about the NEC requirements for grounding and bonding, it is best to consult with a qualified electrician or electrical inspector. They can provide you with the information and guidance that you need to ensure compliance. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to be aware of these local codes and regulations and to ensure that all electrical work is performed in accordance with these requirements. Local codes and regulations may vary depending on the jurisdiction. It is important to check with the local authorities to determine the specific requirements that apply to your area. Failure to comply with local codes and regulations can result in fines, penalties, and even legal action. It is important to be familiar with the local codes and regulations and to ensure that all electrical work is performed in accordance with these requirements. If you have any questions about the local codes and regulations for electrical installations, it is best to consult with a qualified electrician or electrical inspector. They can provide you with the information and guidance that you need to ensure compliance. Ultimately, the goal of grounding and bonding is to create a safe electrical environment for people and property. By following the proper grounding and bonding practices, you can minimize the risk of electric shock, fire, and other electrical hazards. Electricity is a powerful force that must be treated with respect. By taking the necessary precautions, you can ensure that electricity is used safely and effectively. Always remember to consult with a qualified electrician or electrical inspector if you have any questions or concerns about electrical safety. They are the experts in this field and can provide you with the information and guidance that you need to make informed decisions. Stay safe and be aware of the potential hazards of electricity.